Okay, sweet. Hey everybody, it is I again, and we're gonna stream some Q&A office hour stuff. You'll notice that I'm still on a PC. Um, I don't have a legitimately justifiable reason why I'm still on a PC besides I am too lazy to set up um, another Mac. So we're gonna keep going with the PC for a while, mostly because basic prep is not really the point where you need to make a choice between PC and Mac. Most of what we have in in basic and premium prep. Although if you're going for premium prep, they're a little bit more like organized and regimented, so I don't like to speak to anything that they're up to. But at least when it comes to basic prep, we're not really doing anything outside of a browser. So if you have Chrome, you've pretty much got what's going on. I've also got a couple of extra things open that I don't usually have open, and it's to try to facilitate better the idea that somebody might ask a question on Slack and I would want to copy code over. So I've got this website called codestitch.io open. If you ever want a CodeStitch link, feel free to send me a direct message. They're really easy to make. But essentially, it's just a shared code editor. I would, draw your attention to, got a function. Well, let's probably make that a little bigger. We've got a function, say hello. It does one thing. It logs hello world to the console, and then we're calling it on line 5. So if we click run, it's going to say, hey, I'm running some JavaScript, and it says that each time you run, and then it'll output whatever you have in the console. So it's almost like a lower weight, which is to say like less bells and whistles version of Replit, which we actually also have open. I've also got a gist open that I had made for something else, and if it becomes necessary, I might start writing things into a gist, to create like notes or something for people after the fact. But not sure. Still messing with the format of this, but mostly just if there is anybody who has any questions, please feel free to holler in the Ask for Help or General channels of Slack. I think there should be a link in the description of this video to get there. But other than that, somebody had asked about they asked about my doing this highest scoring word, and unsurprisingly, this question comes up a lot because there are no solution videos, whereas for most of the rest of the course there are. So I'm probably going to start off the stream by doing this highest scoring word. And since there does not seem to be anybody here, which is good because that probably means most people are signing up for premium prep, which is nice. Well, yeah, no, that is nice. But that said, probably going to work through things nice and slow, and this might be one of those days where we ended at about half hour, 45 minutes in, just because, well, I'm not really sure why. I guess since this is recorded, maybe people are assuming they'll watch it later, so perhaps the content should be more directed and professional, but that's okay. Anyway, given a string of words, you need to find the highest scoring word. Each letter of the word scores... Each letter of a word scores points according to its position in the alphabet. Boy, that's awkwardly worded. Excuse me. A is equal to 1, B is equal to 2, C is equal to 3, etc. You need to return the highest scoring word as a string. If two words score the same, return the word that appears earliest in the original string. All letters will be lowercase, and all inputs will be valid. Well, that's nice. Whenever they say all inputs will be valid, essentially what they mean is that what I mean is, well, other people have started writing problems, so I should say what we mean. What we mean is that you don't need to worry about this ending up as an object or an array. One of the things in JavaScript that bothers people from languages like Java is that you can call a function, and the function won't tell you you're calling it with the wrong type. It'll just try to run whatever you did, and JavaScript is loose enough that sometimes it ends up actually working, where you do something to your input that you really did not mean to, and end up, in trouble, as it were. So let's go ahead and grab this and use my control copy. I still haven't figured out any of the auto key stuff to switch between tabs and things. So I got a mouse, which I love using. I forgot how much fun it was to use a mouse. Anyway, function is highest scoring word. So, all right. So what are we doing here? All letters will be. Well, the first thing we'd probably want to do is figure out a way to solve this problem that doesn't really rely on any code. So if we want to return the highest scoring word as a string, we need to look at all the words in the string. If we're given a string of words, ooh, that's not well worded. What they mean is that they mean like a sentence. So the words coming in are going to be separated by a space. So the first thing that I'm going to do is make them into not a string, and instead an array of individual words. So we'll say something like split input string on a space, and then something like iterate over the words in the newly split array. I'm going to indent my pseudocode 2 spaces here, and this is to indicate to me later when I read this, trying to figure out what I meant when I'm thinking it out. I'm trying to give myself like a hint that, okay, line 4 is going to be happening inside of this iteration. So if I decide to iterate using a while loop, a for loop, maybe like a some kind of higher order function, I just keep in mind that like this is what's happening per iteration. So the description doesn't have to say for each word, it's kind of implied. So what I would do is also probably, if I'm looking for the highest scoring word, I think that I'm going to want to start with a score that is unlikely to be to last. One of the versions that you could do is you could set the highest scoring word to be the score of the first word in the array, and we could do that. Or we could set it to something like 0. Both of those are probably going to get the job done. So let's go ahead and just set it to 0. We'll say something like set highest score to be 0, and we'll say if the score of current word is greater than highest score, then we want to assign highest score. No, highest scoring word. Okay, you know what? This is actually, we discovered something that usually happens when you're doing a problem like this, which is I am operating under 2 assumptions. One is that I can assign the highest scoring word to something, but also have highest score be the initial variable. So that's not going to work. We don't really care what the score of a word is so much as whether or not it is the highest. So what that means is that we're probably not going to want to set our initial highest score to be the first word. We're not going to want to set our highest scoring word to be just 0 or something. We're going to, actually we could just set it to be an empty string, couldn't we? Yeah, we could do that. So let's do that. We'll say set highest or result. We'll say highest scoring word. No, we probably shouldn't just because that's the name of the function. So we'll say set result equal to an empty string. And that way, the score for our empty string should hopefully come back as 0. But the more I'm thinking about it, we might be running into edge cases where we would have some problems. It might be the case that we don't write our function that gets the highest scoring word to properly give us what it should. So, I would imagine it might be a good idea for us to, you know what, I'm waffling too much. That's what happens when you don't eat for too long. Set result to an empty string, that's fine. We'll mess with it. If we're wrong, then we will fix it afterwards. So assign highest scoring word, and I guess we're going to say result, to be, and this needs to be results score. If the score of the current word is greater than result score, okay, assign result to be current word. Cool, and that's going to be it for this function. One of the things that we did not do, which we're going to need to, is how do we get the score of a current word. But what we're going to do is we're going to pretend like we can do that and assume that that'll just be a function. So we'll just take the current word, apply this function to it, and that'll give us the score. We assume that we're able to write that, and so by assuming that, we can complete this kind of like, outer function, as it were. It's not going to be an outer function because they're going to be 2 separate functions, but we can set this function that's going to make use of the other function without really caring what the other function is going to do, because we assume that it'll work. After we get done the iteration, we're going to return result. Cool. So now let's talk about that other function, and I want it to be something like, return word score or return letter score. It depends, because we might do something where we make 2 functions. One is where we get the word score, and one is where we get the letter score. And inside of the word score, we use the letter score several times. I think that might end up being the best idea, only because the letter score is going to be relatively easy, whereas word score, if we try to build it from scratch, might be a little trickier. So we'll say return word score, and word score is going to take in a word, and we'll say this will return the score for a word. And we'll say something like function return letter score for a letter, And a letter is just going to take some kind of like an input, which will only be a one, like a string of length 1, and we'll grab a score from that letter. So we'll say this will return the score for a letter. Now, let's think about what a return word score might look like. This is going to return the score for a word, but let's flesh that out in a little bit more detail. So we'll say set a result or a score to be 0, and at the end we'll return the score. We're going to iterate over the word. We'll say calculate current letters score and add to, well, we'll say get current letter score and add to score. Oof. We'll say word score and return the word score. Get current letter score and add to the word score. Okay, cool. So that's pretty much how we would do return word score. And again, we'll come back to code this once we get an idea of what the whole picture looks like. At least that's how I like to do it. Sometimes. It depends. So this will return the score for a letter. So here's where actually we're getting down to the nuts and bolts, because returning a word score is just the same as adding together things with one function applied to them. And highest scoring word is basically, longest palindrome, the module 2 problem that we did, or that, is in the course. But returning the letter score is a little bit, might want to take a look back at this. So it says, according to its position in the alphabet, A is equal to 1, B is equal to 2. Now, this might not be immediately obvious. And the reason it might not be immediately obvious is because you might not have done problems like this where you were made to sort of create some kind of like an abstract entity that gave you an ability to do something like this. I'm making it sound much more complicated than it is. All I'm picturing is that if I had some kind of like a string or an array where all of the letters in the alphabet were like right shifted by 1, the index of that letter inside of that string or array would be the score for that letter. So what I'm picturing is, let's consider a string like something 0a. 0a dot index of a is going to give me 1, which means that I can calculate the letter score for a by checking for, oh gosh, get away from me. I don't know what that is. Oh, that's just right click. Okay, so this will return the score for a letter, 0a. If I extend this all the way out, that's going to give me a way to check the index of a given letter in this. So we, let's get this all the way out. D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, V, W, X, Y, Z. I feel like I did this on a stream one time and forgot how the alphabet went. It was embarrassing. But anyway, now that I have this, what I could probably do is, well, I could probably just look straight for the index of. I can't remember if string has an index of function, so let's just assume that it doesn't, because I don't want to pretend that it does. So what I'm going to do is I'm going to say return this string, and then I'm going to call a couple of methods on it. I'm going to say dot split to turn it into an array, and then I'm going to say dot index of letter. Now let's follow this back. If I split this with the first value, because of the values in the array being a single character string, at the index where the word score is like what we want the letter score is where we want it to be. So if I call return letter score on C, it's going to give me 3 because it's at index 3. So letter score now works. So if letter score works, let's go ahead and say, by the way, when I'm saying letter score works, what I'm doing is pretending that I tested it, and also I have this written down because it's a bad idea to just sort of like go off the cuff, especially when you haven't eaten that much. I hate to keep mentioning that, but I can feel my brain cells kind of like struggling, so wanted to give like a heads up. So I'll say let word score equal 0. Then we'll say for I is equal to, I guess we should use let I equal to 0, I is less than, what are we doing, word dot length, I plus plus. Man, this keyboard is just not what I'm used to. That's okay though. Sometimes you'll be in a situation where you have to do something you're not used to, and you'd be amazed how much slower it feels than it actually is. Sometimes. So here we go. Get current letters score. So the current letter is going to be word at I. To get the current letter score, I'm going to say return letter score on word at I. Oh yeah, it's function to get all the way from like one end to the other. Okay, so get the current letter score and add to word score. So we'll say something like word score plus equals return letter score for the given position in word, which is of course a letter, and then we'll return the word score. So at this point, seeing as how this function is mildly complicated, let's go ahead and run a quick test. We're going to say something like console.log return letter score of, let's say, D. D is one that's pretty easy to remember because it's 4. It's not really that far into the alphabet. So we'll run this. We get 4. Cool. Let's try F. Cool. I think Z should be 26. Gosh, I hope. Excellent. So cool. So letter score seems to be working. Let's try ZAB, which is going to be 26 plus 1 plus 2. So for those of you playing the home game, that's going to be, which is actually nobody. This is the first time I've had this where there's nobody commenting in the chat, so I'm nice and relaxed. And it's like, hey, nobody's really watching anyway. By the way, I know you're probably going to watch this later. I'm sorry. I don't mean to make it sound so flippant, but I encourage people to try to have fun with coding as much as they possibly can, especially because, career changes can be scary. And if this is a career change for you, you might have run into a lot of people that take coding extraordinarily seriously. And there are some serious aspects to it, and some serious stuff that you can do with it. But like everything, there's always some room for frivolity, especially if you make room. So Z, 26 plus 1, 27 plus 2, 29. So let's go ahead and make sure that this is returning -1. So what's the problem? -1 is what happens when we're looking for something in index of and it's not there, which means that, hey, I don't really know why I would be looking for the letter score if I'm putting a word in here. So let's go ahead and adjust this nicely. We'll say return word score, which is what we want. Run this. I think it was 29, and we are in good shape. So let's go ahead, excuse me, and get rid of this. Now that we have both return word score and return letter score, this becomes one of those, find the greatest or the longest string, but instead of saying .length to each string, we're going to say return word score on each string. So set result to be an empty string, and again, this might not be what we should do, but we'll find out in a couple of moments if that's the case. Also, if you see me write let and you're not sure what that is, just use var. Later on, when you discover more about scope and about, well, actually, that's pretty much it, scope, you'll way that they really didn't need to make use of what let can let you do. So to not know at all about var does not leave you in a very good space as a JavaScript developer. So there you go. So we'll say return result at the end. Split the input string on a space. So it's going to be something like let words equal string.split on a space. Iterate over the words in the newly split array. So we'll say 4. And you don't have to do this, but I'm going to use, no, you know what, I'm going to use I. And the reason is that I think you can. So we'll say let I equal 0, I is less than, yeah, it'll work that way. Cool. So let I equal 0, I is less than words.length, I plus plus. Alright, mouse. So here's where we want to take a quick look back here. It says if two words score the same, return the word that appears earliest in the original string. What I read when I see that is I want to use less than or greater than rather than less than or equal to or greater than or equal to when I'm making the comparison here. If I say greater than or equal to, it's going to keep replacing it with whatever word is equal to that greatest length word or greatest high score word each time that it meets another word that scores as high as whatever the highest scoring word is. So in order for that to remain the first one, we need it to be greater than. So if it meets any words that have the same score, it'll be like, hey, cool, but I'm not doing anything. If score of the current word is going to be a very simple process, we're going to just say return. I guess it's not that simple of a process, but it's straightforward given the pre-work that we did. We were able to set up a function that we built kind of, one very small piece at a time, and we had a description in pseudocode about what each part of it is. So that's why I say when it's really simple. It's simple because to get the score of the current word, we already did all the work. We figured out a way to write a function that made use of another function, all of which gives us a function that we can just say, you know, the same way we might say, like, you know, words at I.length. We just say, go on then. Oh, go on then. Return word score at words at I. That's going to be the first one. We can say greater than, and we need it to be that same function called on result. So if return word score of words at I, the current word's score, is greater than the score of the result, which is what we're saving as like our highest score. So now that I say that, why don't we call this highest score? Highest score. Oh, I remember. We did this a second ago because we already called this function highest scoring word, so we'll just leave it as result for now. Excuse me. So we'll say if return word score words at I is greater than return word score of result. Excuse me. Sorry, I've got one of those like tickle in the throat kind of deals that only manages to creep up whenever I'm about to stream. So we'll say assign result to be the current word. So that's where we just say result is equal to words at I. All right. So we could run this, but it's not going to do anything because we don't have any test written. So what we're going to do instead is just grab all of this. Code seems to be in, you know, relatively good working order. And by that, what I mean is that I ran the code and it didn't tell me, you know, you have a curly brace out of place. Which actually, let's be curious about that. Give me back my. There we go. So let's just delete this and see what happens if we run it. Okay, cool. So there is a little bit of like even though we're not running the functions, REPL is kind of, you know, finding out if those functions are at least syntactically, you know, mostly accurate. So we'll copy all of this, come back to our more advanced practice section, paste it on in, look at the fruits of our labor for a moment, but then hit run test because that's the important part. Excellent work, everybody. So that's how you do highest scoring word. There's another version of this that I had that used higher order functions. If you're ever curious about that, please feel free to send me a DM or, you know, I'll send you a version of it because you want to figure that anytime you have a for loop, you could use a higher order function, and higher order functions are, you know, they're pretty fun. So, nothing going on Slack. I feel abandoned. Not really. It's actually kind of nice that people are probably able to get through the material on their own, or they signed up for premium prep. Oh gosh, or they find the stream terrible. But I don't find that to be that, you know, what's it called? Doesn't matter that much. I enjoy the streaming for its own sake, he said, crying into his, what do you call it? I don't know. Handkerchief? I suppose that means I'll have to get a handkerchief. Could you give a simple example with reduce? Yeah, sure can. So reduce is a higher order function. Let's go ahead and do a little bit of background. We'll check out MDN reduce. MDN reduce JavaScript, or MDN what I'm looking up in JavaScript. JavaScript looked up like this is a great habit to get into. You'll come right here to the MDN website. This is like a professional developer level website, which means it's going to have some stuff on it that's a little bit like, oh god, what is that? This is also what drives me nuts about these kind of websites, is that it's like, good. So in case you need to use reduce, you'll have to make sure that you know how to use arrow functions. And it's like, but arrow functions are like, they're fine. I'm not going to be using arrow functions because I don't think that they are of significant utility for beginners. But essentially what this says is reducer is a function that takes in two parameters and it returns the first parameter plus the second parameter. Now the part that's annoying about this is that what it doesn't tell you is that the value of this first accumulator can actually be set as part of the function, and I don't think that that does a very good job of it in this capacity. Oh, here it is, right here. The second value that they're passing to reduce. The first one is an actual function, which is why this isn't. Actually, let's just grab all of this and go ahead and fix it. To be sure, we're going to fix it for our appreciation, not necessarily compared to, like, you know, anybody else's. Let's copy all of this, or, you know. All right, so first thing I'm going to do is get rid of these consts because I don't care about const. The second thing we're going to do is we're going to make this a function declaration. We're going to say function reducer. It's going to take an accumulator and a current value. And for those of you who are curious what a arrow function like is, what I'm doing is a decent like approximation of what it's doing. That's another one that drives me crazy. It has something called implicit return, which means that what it's doing here, it implies that this needs to be returned. However, if you need to return an object, I don't think you can actually do that because it thinks that you're trying to get rid of the implicit return. However, don't take my word for anything. Like, and I mean that almost for everything except for the stuff that's actually in basic prep. You always want to take everything that I say with a grain of salt and, investigate it on your own. And that's true for what you hear a lot of people say. So return accumulator plus current value. And okay. So cool. Reducer, reduce 5. Okay, cool. So let's go ahead and run these, and we'll see we get an output of 10 and an output of 15. And all we're doing here, what reduce does is reduce is assuming you will call it with a function that takes 2 parameters. It's going to look at the second argument that you call reduce with and see if it's there. If it's not, it's going to assign accumulator to be the first value in the array, just by default. And then it's going to skip and basically reduce the rest of the array. So what happens here, and it can be helpful sometimes to use console.logs in a way that tactically helps us figure out what's going on. So we're going to do that. What we're going to do is say something like console.log accumulator. All right, let's see if we can do this shift function. All right, cool. And this one's going to be current value. So all we're doing here is giving ourselves an idea of what's happening inside of this callback function for reduce. So whenever you have something like reduce, you want to picture it's like, okay, it's going to iterate over the array. Like it's going to do something to all the values. What reduce does is it tries to, according to this reducer function that you give it, reduce the array to some single value. The fun part is that a single value could be an array. So one of the fun parts about reduce is that you can use reduce to implement filter. In fact, if nobody gets lively on the chat, which that's totally cool, I might do that because it's kind of fun to see how flexible reduce can get. Let's go ahead and run this, and then we'll have a look at the output. So as you see, the first time through, the accumulator is 1 and the current value is 2. So for the first iteration, what it does, as I said, is it's going to look and see, okay, hey, you only passed in a function. You did not give me a, they call it a starting value for the accumulator. And so one thing that I could demonstrate with this, if we wanted to just have a quick look, is if we pass in 0, we're going to see something similar but not identical. So what's going to happen is the accumulator starts at 0, but the current value's first value starts at 1. So if you do not pass a value for the start value, it kind of just is like, all right, I'm going to take the start value as the first value of your array and just kind of keep going. You'll notice that's kind of similar to how we do if we're trying to find like the shortest word in an array. Sometimes we'll just take the first value in the array and be like, okay, this is the shortest word for now. That's not what this is doing exactly, but it's a similar idea. If we do not pass a value here, as we did previously, then you'll see again, it just kind of skips it. It's like, all right, well, the accumulator is 1 then, and the current value would be 2. We end up at the same result, though. The example below had a version where we pass in 5 as the first value. And what that's going to do, of course, is, well, start the accumulator 5, but the current value, again, is 1. Now that we have, like, a value for that starting value, it says, okay, well, I'll just go to the current value as whatever the first value in the array is. Most important thing to remember about reduce is that whatever you return inside of your reducer function, that's what accumulator becomes the next time the function runs. Reduce in its guts is basically saying that. It's like, okay, run reducer and then run it again with whatever value was just returned from it as the first value, and then extend the current value to be whatever the next value in the iteration is. Something like that. I'm confused about... Ooh, for the person who asked about reduce, does that work as like a quick example? Because this is like the most generic case. It's like you add up a bunch of things in an array, and you just kind of see this a lot. Like, the other version that you'll see is that instead of actually writing the function reducer outside of it, what people will do is they'll write a function inside here. They'll call it like an anonymous inline function. And what you do is you say something like, accumulator, current value, and then say something like return accumulator plus current value. You'll see that from time to time. And all that is basically this is an identical copy in all the nuts and bolts areas of this. So when I say reducer, I'm saying something extraordinarily similar to a function that just does what reducer does, written out like in full rather than being called, which is nice. So we'll wait for that person who asked about reduce to get back if this was a satisfactory explanation, but excuse me. I am confused about comparing arrays to arrays, objects to objects, or arrays to objects. Can you give some examples? How do you compare them? Okay. So one of the things that you'll notice if you get into module 2 is I can say something like variable my array is equal to 1, 2, 3. Nice little array, and I want to say something like console.log my array is equal to an array with 1, 2, 3, which should work, right? I mean, they're identical, they have the same length, they have the same values, so let's go ahead and run it and see what happens. False. Now the reason it's false boils down to what triple equals is doing, what the equivalence operator is doing, is it's saying, hey, my array is this very specific location in memory that houses this my array value, named this with, yada, yada, yada. Then it says, okay, this other array, literal, 1, 2, 3, is not at that same address, so they're not the same. It doesn't really care that they have the same values because of the way that the equivalence operator works. Same thing for objects. Objects get a very similar treatment where it's like, okay, I've got an object, it only has one property, just a key of A and a value of 1. So if I were to compare it directly here, hopefully that would work because they're the same, right? Now, I get it. My array is not really what we're looking for, but it's okay that we call it my array for now. But it's telling us false, right? It's saying, hey, like those are not equivalent. It's the same idea. It's just like, hey, those do not have the same memory address as well as the same values. And in fact, it doesn't actually even care about the values. First thing is just like, hey, no, that's not located at the same place. One of the things that's frustrating about that, though, is that if we were just to say, and let's just say my value here, that's going to be a little bit easier because we're going to change it around a couple times. We'll say my value, let's say is equal to 1. Boy, this takes forever. Anyway, so if we run this one's going to be true. And the reason is a little bit more complicated than we want to just kind of like ad-lib. So what I would suggest is there's actually a part in Module 2 where they go over this in as much detail as you need to hear. Essentially what is happening is that there is a way that your JavaScript interpreter, yeah, that's a close enough working way to describe it, is not going to compare values that are arrays the same as it will for less complex objects. Essentially, that's the distinction between scalar and not scalar. It's the same reason why we can do something like this. My value is an empty string, and in order to find out if my value is an empty string, I can compare it to an empty string literal, like a literally created right here in line for the purposes of comparison, and get back true. But I can't figure out if an array is empty by doing the same thing. If I look at an array to see if it's empty by comparing it to an empty array, we get that same idea of like, I created a literal array here with a different memory address than the one that you assigned here. So, they're not the same. Which brings up an important point. Excuse me. One thing that we do in prep is we teach you kind of how to hack into an array, as it were, and compare the values and the lengths. So what we can do if we can't compare them directly just by saying, my array triple equals this array that looks exactly like it, is we can set up a function that takes in the two arrays and literally compares their lengths and then iterates over them and compares the values at the same indexes. And if the lengths and the compared values are the same, then we say, technically, they're the same array. Now, of course, the problem comes up, it's like, what if one of those values in the array is an object or an array? And it's like, great question. That's actually what breaks this, and why you don't want to take the testing section, like, it's not literal. That's more of like a metaphorical way to get you used to the idea of why software engineering is not the same as programming. And what we mean by that is that coding a solution that works versus coding a solution that is easily proved to work are not identical operations, and that's where testing comes in. However, being that this is 2020 and software engineering has been around for a while, there are things called test suites, which actually will give you an array of functions and methods and things that give you the ability to compare objects directly. One of the things you'll see in the tests down here, like if we were to get a test wrong, let's go ahead and let's move this over 1 so everything is off by 1. Oh, actually, that doesn't change anything. No, and it wouldn't, right? What could we do? Let's say, plus equals 1, or here. Maybe that'll mess it up. Okay, cool. Excuse me. So what this is basically saying is that this to deeply equal is actually part of the functionality of the test suite that's running behind this. So to deep equal is a set of methods that they give us out of the box for this test suite to compare things like objects or arrays. And it does what one might do in those cases. The problem for writing like a, hey, let's compare objects, we have you just JSON.stringify both. And the reason is that that's kind of like a close enough way to do it. Go on. So let's walk through that. Oh, come back. Go on then. I love Replit, but I'm not a huge fan of this. Although, to be sure, it might not be Replit, it might be me. I don't think so, though, because I'm currently working fine. Go on, then. Time for a refresh. I don't care. Ah, good man. Yep, sweet, cool. So let's come back here, and, well, what we could do is we could JSON.stringify both, and what that's going to do is give us like a hacky solution to compare two objects. The problem is that we might not have those properties be in the same order. Like, so let's say we have two objects. We have one that's like A1, B2, and we're going to compare it to B2A1. Now, an object is not necessarily an ordered collection of properties. It's a little different than an array. It's a lot of times remains in the same order, but we don't want to assume that it's going to. So ostensibly, these have the same properties, meaning the same associations between keys and values, so we could theoretically assume that these are like, the same object. The problem with JSON.stringifying both versions is that it's not going to work. So what we would want is we would want some kind of way to go into both objects and compare across to see if they have the same values and the same keys and properties. However, objects can get rather nested the more complicated that they get, and the more complicatedly nested that they get, the more difficult it would be to visualize how you might compare completely across two objects. Again, in the materials that we provided, there's a link to something called object deep equal, which we could probably just go ahead and look up. Go on. Object deep equal JavaScript. JavaScript object deep comparison. Comparing x equal to y, where x and y are values, return true or false. Comparing x to y, where x and y are objects, returns true. See, that's why I don't love these first things, because it just draws a distinction between values and objects. And I guess that's probably okay, but sometimes that can get pretty difficult. So it never hurts to click on Stack Overflow to just see what's up. See, nice and fast and limited. But doesn't work if you have... I swear I didn't see this. I just think that most people think the same when they're trying to get quick things across. But yeah, slow and more generic. This is, as you can see, a little bit more complicated than we want to, mess with prep students about. So that's kind of long and short about that. For the person who asked about whether or not comparing arrays and objects, did that address your question? I'd hate to think that you asked a question and it didn't address it. But at the same time, the question you're asking is kind of like, if you have noticed inconsistencies in the logic behind what we're asking you to do, you are correct. And you are being asked to do that more to prove the idea of, that you understand testing and that you can, get your head wrapped around the idea of writing functions that take your functions and kind of like prove that they work in some capacity. But we do it with like, limited tool set, so it's not necessarily like the end all be all. Ah, good, of course. You are most welcome. I think I had some direct message questions. Okay, so here's a question that I had that was like, can you solve this problem using recursion? Write a function which takes an array of unsorted numbers and a target value, returns the indexes of two numbers that equal the target sum. For example, 1, 9, 5, 3, so we got an array and a target value. Return 2, 4, since 5. Okay. The answer to that question for the person who asked it is, can I solve this problem using recursion? No. Can a person solve that problem using recursion? Probably. But whenever you're thinking about recursion, you want to think of like doing one small task that repeatedly shrinks the problem from a large problem to a very easy to solve and then like the answer to the question problem. So the reason why it might be a little bit tricky to use a recursive solution is not necessarily to do with recursion as such, but more to do with if you are in the like skill level that we're aiming at right now, brute force iteration is kind of what we want you to do on something like that. However, let's picture the idea of why a recursive solution might be useful in that case. See, I'm only coming up with if you just wanted to use recursion. To me, it's kind of like, well, I suppose you could use recursion, but honestly, recursion is one of those where it's a very tricky tool to learn because of problems like this, where it might seem like, oh, I'll just, do it recursively. And it's like, well, sometimes recursion is a little bit more complex than you actually need. But that said, the other version is that we can always just kind of look it up. We'll say, find a sum pair in an array using recursion. Now, I know we're probably not going to get that exact question, but we might find something. Sum an array of elements using recursion. Sum of even elements of an array using recursion. Find pair with given sum in an array. That looks like we're iterative. Finding pairs that add up to a given sum using recursion. Ha! Let's see if we, oh, this is Java though. Yeah. So maybe it's possible, but a lot of times, especially in prep, I don't like to mess with things that are not likely to be super applicable for the technical admissions assessment. Since recursion is not on the technical admissions assessment, I give myself a little bit of a break by I don't really mess with it. Mostly because I'm a terrible teacher at it, and that inherits from my not being that good at it. So the answer is yes, you probably could. For me, I probably could not, and I'm not going to do what I did like 5 or 6 weeks ago, where I'm like, oh, I'll give it a try, and then butcher it. So if you have any significant issues with that, please let me know. And if you have any solutions you want to send my way after you've solved it, please always feel free to do that. So hopefully that is satisfactory for that person, but if it is not, hopefully they will make their opinion known. All right. Cool. So I'm not addicted to the whole an hour thing, but since we're approaching that maybe with time for a couple more problems, if anybody has any questions that they'd like me to go over, any issues that they're currently facing, or opinions of mine they'd like to hear, please feel free to ask a question in the either the general or the ask for help here. Although I do have the Slack open, so if you have if you end up asking it in module 0, that's probably not the end of the world. I like this problem. Extract a domain name. It's one of those where the first couple ways that you think to solve it don't usually work, and it's either those ways or similar, or what's it called, a regular expression. And I hate regular expressions. Oh, regular expressions and I do not get along. Again, for a similar reason, mostly because I'm just terrible at using them. Oh, to that person, my pleasure. Sorry, that was a direct message. In general, always feel free to send me direct messages while we're doing the live stream, or otherwise too. It is not necessarily the case that you need to be, let's say, public-facing proud of the questions that you're asking. So I'm never going to say your name if you send me a direct message during a stream and I answer a question. But I don't see that as like what would you call it? That's a perfectly acceptable way to ask questions as far as I'm concerned. I never asked anybody about sound levels or the video quality. Hopefully that's just, enough to get through it. Oh yeah, this is from one of the things I did on the YouTube channel that I'm streaming this on is I started reading like a live read through of Eloquent JavaScript. Eloquent JavaScript is a very, very useful book. It's one of those books where it's like the people who wrote it just seem to be like that we just want to watch the world learn types, where it's available free online as a PDF and as like a code sandbox. So like you can read through it and all of the code examples, you can click on the code examples and like run them in the like, you know, where you're actually reading the code, or sorry, reading the textbook. And so they also have you know, practice questions at the end of each chapter, and I think I've gotten through chapter 3. So if you ever feel like checking that out, these are all linked in the YouTube channel itself. They do a lot of this stuff, which I'm not a fan of, but that's okay. The only problem with Eloquent JavaScript, and why I would advise caution if you are, you know, still preparing for the TAA, is that there are concepts that are introduced rather rapidly that are introduced more gradually in our course. So closure, recursive, the call stack, lexical scoping, all that kind of stuff is in chapter 3, but I am of the opinion that it is a better idea to get used to what a programming language can do in general and like kind of generally wade into the idea of it, rather than be like, hey, here's the nuts and bolts of everything about JavaScript from top to bottom, because, well, that actually exists. There's a book series called You Don't Know JavaScript, another great one, written by a guy who had some affiliations with Hack Reactor previously. I met him a couple times. He's a pretty cool guy. He's another one of those where it's like, man, these people just really like giving away their stuff that they work on really hard for free. He sells the books as well. You can buy them, and you know they're a quality book series. However, they're available free online, and he regularly updates them online. In fact, I think if you go into the SEI side of things, oh no, we are on the SEI side of things. If you go into the bonus prep modules, a lot of the lessons just link out to like a section of one of his books, because one of the, how did he describe it? He was basically like, if you've ever seen that book, JavaScript, The Good Parts, he hated that book. As far as he was concerned, the idea of going towards a programming language and deciding what you like and don't like about it without getting into the nitty gritty is like the height of dishonor, I guess. I'm sure that he would describe it a little bit more subtly, but this was, in addition to probably tons of other things, a response to that. Kind of like a, hey, no, there are tons of good parts in JavaScript, not just the parts that you like, and so let's go through the exact details of what's going on. One of the things that I thought was kind of cool was what actually happens when you write, like, you know, var my array is equal to an array, like literally what happens word, letter by letter, and, you know, it's a decent way to give yourself more of like a leg up on language composition in general, maybe. Also stuff like, you know, double equals. Like double equals was to perform something called type coercion, where it tries to change the variables to things that it thinks you mean. So by that, of course, we mean, let's say my value is equal to, excuse me, no, that's not it, 1, like that. We can, excuse me, say my value double equals 1, and, oh boy, if this doesn't work. Yeah, we're going to get true. And what's happening there is, and here's my point, is that I don't know exactly what's happening there. Does it change my value to be like 1 and then compare them, or does it change this one to -1 and compare it for that way? And apparently there's like a whole list inside of the spec for JavaScript that gives you all of those determinations, like if it's the first operand or the second, and what it changes it to or doesn't, and it's all in his book, amongst a bunch of other very useful but possibly way too technical information. So that's, what's it called? You Don't Know JS. That's by, and it's by Getify. So if we go ahead and, come on now, copy, no, that's not it. We'll just cut all, what? Back up. I'm gonna just go ahead and paste this in here, and I think he has them on GitHub at this point. Yeah, right? So you can buy them on Amazon, as you see, but you could also just hop in here and be like, hey, here they are, all the books. So this is a second edition, so he hasn't started the second editions for these yet, but if you go to the first editions, of course, you can find all of them. You know, here it is, free online. Here's the first one, up and going. So we come in here and it's like, hey, let's talk about programming. So it's like, if you ever find yourself wanting to read, this is a great place to start. This is a very, very robust and detailed version of things, and the chances of his being wrong about something are pretty minimal, because I think he makes a lot of his reputation over being the person who actually knows. So, always nice. So cool, so it's about 7:18, there's about 12 minutes theoretically left, but I'm not seeing a lot of questions, and that's okay. If you have any questions or issues you'd like me to solve for next week's stream, please feel free to send me a direct message. Anytime that anytime that you're online, always feel free to message in any of the channels. If you do not like the answer you get from somebody else, you don't need to worry about that, but you can always feel free to send me a direct message. It's one word, David Coleman. Usually able to get back to people within a day, 2 at the most. If I don't get back to you, it's an accident. Never ever hesitate to send, like they call it, bump, B-U-M-P, and that's literally a message that you send that sends the person another notification. So always feel free to do that. Until next time, keep answering each other in the channels. Everyone's doing a very good job of that I've seen so far. Let me know if anybody needs anything, and we'll go ahead and do this again next week. After I say that goodbye, I usually like to hang around for like another couple seconds in case somebody was like, oh no, I thought there'd be more time, I'm gonna type a question real quick. But I literally haven't seen almost anybody in the chat chatting away. So let's just call this an off week for class participation, which is fine because there was like 4 weeks in a row that was off for streamer participation because we just didn't have the stream, but not to worry. One of the best parts about Basic Prep as far as I'm concerned is that they essentially let me do whatever I want in terms of trying to offer free resources to people. So if you ever see something that would be of utility in that realm, it's like, hey, I found this free tutorial, I'd like to see somebody do it, always feel free to send that stuff my way. The philosophy is this: premium prep is available for people who can afford it, but basic prep is also supposed to be there for people who can't. So if anytime you think of something that could make basic prep a little bit more robust or better, or just more effective for you, always feel free to let me know. Delighted to hear those kind of things. And yeah, thanks everyone. We'll see you next time.